Okay, we're going to talk about scatter plots today. Scatter plot's another very simple concept for this unit. Hopefully this will be a quick, brief introduction to scatter plots, and then we'll work with it tomorrow. I'm going to try to make it short, so we're not going to have a whole lot of fancy stuff in this particular video. Alright, some key, well, first of all, what do you think of when you think of the word scatter? If you're like me, I think about when I'm mowing my yard or when I was a kid and I used to step in an ant pile on accident or on purpose, whatever, and all of your ants just started scattering everywhere. That to me is kind of a definition of the word scatter itself, that root word scatter. However, there's times where we actually have organized scatter. If you think about a fire drill, when we all go outside, when the fire drill's pulled, we kind of have an organized scatter. We all kind of go in one direction. When you step on an ant pile, the ants just kind of go everywhere, but like a fire drill, we're all organized and have like I said, one direction. In scatter plots, we're going to have both types. We're going to have an organized scatter plot, and then we're going to have kind of an unorganized scatter plot. So some of the key vocabulary you need to understand is positive correlation is one of the words. Positive correlation means when you increase the x value, you also increase the y value. So when that happens, your dots are kind of going in a positive direction. They're going upward. Positive is up. Okay? So as your x increases, your y also increases. That is your definition for positive correlation. As your x increases, your y increases as well. And again, you can see the direction of this line is in the upward, or the direction of the data, or the trend of the data is upward. Okay? So that's positive correlation. All right? Again, looking at a single quadrant graph, my next key vocabulary word is negative correlation. Okay? Negative correlation says as your x increases, so in both cases our x is increasing, then your y decreases. Okay? So in this case, as I go towards the right on my x value, my y values begin to decrease. So as you can see, if you look closely, my line or my trend is going in a downward angle or a downward position. Positive and negative correlations are both those organized style of scatter. Okay, we have a good direction. We can see where it's going. The trend is down. Positive, the trend is up. That's the organized. That's the fire drill type of scatter. Okay, it's very organized. Okay, again, and this again is all based on a single quadrant graph. A lot of times when we're dealing with scatter plots is something that we briefly talk about. We don't talk about it a whole lot. It doesn't have a lot of application in Algebra 1 per se, but it does have a lot of application when you talk about the business world, because we'll take data and we'll put it onto a scatter plot to kind of look at those trends. Those trends are very important. Okay, so again, we only really use one quadrant on this. We don't use a whole 4-quadrant Cartesian plane. Okay. All right, so let's look at our next key vocabulary word, which is no correlation. No correlation is the ant pile in which your ants go everywhere. It's when your dots are going all over the place. So on no correlation, we can't tell what's happening to y as you increase x. So like on the other ones, I had arrows. In no correlation, I can't tell if the data is going up, the data is going down, the data is constant in one direction. I can't tell that at all. So no correlation, like I said, is that ant pile going crazy, okay? And so the dots are going everywhere. They can be going this direction, they can be going that direction. So no correlation, you really can't tell what the trend of the data is, okay? So positive correlation, negative correlation, no correlation. So really quickly, I want you to think about this and maybe jot this down in a journal. What do you think, what kinds of things would go with the positive correlation? What kind of relationships would go with the positive correlation? Because remember, x and y are related. And we'll talk more about that later, but x and y are related. So let's think about things that would create a positive relationship. How about your age and your height? The older you get, that might be your x value, the x increases, so the older you get, the taller you get. That's a positive correlation, right? So as I get older, I increase. I also get taller, so that's going to go upward. Okay? What about another one? How about the older I get, the more I eat, right? The older I get, the more I eat, especially when it comes to guys. Maybe ladies, it's not quite the same. But for guys, the older we get, the more we eat until we hit a plateau. So if we're babies, we don't eat quite as much, but as we get older, we eat tons, okay? We eat tons. How about some ideas from examples of relationships that have negative correlation? Negative correlation. How about, let's see, what's a good negative correlation? Something that as you increase, the X decreases. How about the value of a car? When you buy a new car, the longer you have the car, so the length of time you have the car is your X value, the longer you have the car, the value of that car decreases. So the more I have the car, the value of that car is going to go down. Okay? So the longer I have that car, the value of that car is going to go down. How about this? How about the faster I drive or the longer I drive away from my home, the further away I get, right? So my distance from my home. So here, if I'm looking at distance to home, I'm sorry, let's go the other way. Excuse me, I may correct myself. If I'm far away from home, the longer I drive, the closer I get. So if I start at 100 miles away, the further I drive, the longer I drive towards my house, the closer I'm going to get to it. That's a negative correlation. That distance from your home decreases. So if you're on a bus, okay, you start at the school, you're far away from your house. As the bus continues to drive, the longer it drives, the closer to your house it gets in most cases. Okay? So those are good examples of positive and negative correlations in the real world. Okay? How about some examples of no correlation? Things that basically are not related whatsoever. How about the older I get, the flavor of ice cream I like? Those two things are completely not related whatsoever. Okay? So the older I get has nothing to do with the kind of ice cream I like. Okay? So that they're not related. So I can't tell if the older I get, I like more chocolate versus vanilla versus strawberry. Okay? How about, let's see, what else can we do? How about how tall you are depends on the color of your shirt. Okay? Does the color of your shirt have anything to do with how tall you are? No. So you can't make any kind of graphical representation of that whatsoever. So those are some real world scenarios. Okay? And then finally, our last bit of key information is the line of best fit. Okay, line of best fit. So what we have to do when we talk about line of best fit, this is also known as a trend line. A trend line. Okay, this kind of helps us determine what the trend is. What we would do is we would take our data, our scatter plot, okay, and then what we do is we would draw a line, what we call a line of best fit, through that data where that line touches or gets close to as many points as possible. So here, I'm going to draw a line kind of in the middle of all that data, and that becomes our line of best fit. Okay? Most of the dots are centralized around that line. So this is my line of best fit. The more your data is spread apart, so the closer it gets to no correlation, the harder it is to draw that line. If I created another one where the dots were real tight, it'd be easier to make a line of best fit or a trend line. So what does that trend line help us do? That does a couple of things. First of all, it helps us find or kind of get an idea of an average. Okay, an average helps us find a rate of change. And again, all of this is an average rate of change. When you have data that's on a scatter plot, none of it's perfect, none of it's exact. So this trend line is an average, okay, of information, of data. It also helps us predict. If I erase these dots up here, can I predict what's going to happen up here? Wouldn't I assume or guess based on my trend line that I'm going to have some more dots right here? So this helps us predict future information. This is what businesses use this for all the time. Is they create this trend line and say, hey, our company is growing, and if we should grow on an average of an X amount based on the data. Okay, so people use this all the time. That trend line helps us determine whether it's, and it also helps us see positive and negative more clearly, but it also helps us determine future probabilities. It kind of allows us to make predictions. So realistically, that is pretty much the nutshell as far as scatter plots goes. Now, I want to clarify a couple things. Again, we talked about the definition of these things. I've shown you kind of some visual representation, but the question is, where does the data come from? Well, the data can come from anywhere. You create a table. You can get a table of information like we talked about the other day. We did data collection the day before. You get that data collection information, and then you take that table, that data table, and you plot the points wherever you want to. And that's where that data comes from. So whatever you are trying to research or investigate, you put it into a table, and then you plot that information points on a one